Alright, so after that ridiculously long introduction, finally ready to start the problems, and the introduction that I gave really is to get through the first 16 problems in section 5.1. So the first group of problems, the first part of each problem says to find the x-intercept and its multiplicity round to 2 decimal places. Some people will call x-intercept 0, so I just put that parenthetically there just in case you hear that word. A 0 is an x-intercept. So if I look at the problems between 1 and 16, we'll see a bunch of functions that are polynomials. Some of them are factored, some of them aren't factored. If they're factored, that makes some things easier to find and others more difficult. If it's so, they kind of, I don't know that it's easier to have them factored or not, but I put the factored ones first because finding x-intercepts is really nice when a polynomial is factored. So I'm going to just jump in and do 2a. 2a asks me to find each x-intercept and its multiplicity. So to find an x-intercept, you're just going to take the function itself and set it equal to 0. So I'm going to take x minus 5 squared times x plus 2 and set it equal to 0. And I can write this without the exponent. So this is going to be x minus 5 times x minus 5 times x plus 2 equal to 0. I'll go x minus 5 equal to 0, x minus 5 equal to 0, and x plus 2 equal to 0. For the x minus 5s, to get the x-intercept that those generate, I'll add 5 to both sides and get an x-intercept of x equal to 5. And the x plus 2, I'll minus 2 from both sides and get an x-intercept of minus 2. So part of my answer to part 2a is there are going to be 2 x-intercepts. One's going to be at the point 5, 0. The other's going to be at the point negative 2, 0. So that's part of what it wants, but it also wants the multiplicity. And again, the multiplicity, that's part of the introduction to this section. The multiplicity is either going to be even or odd. The x minus 5 squared, because it came from a factor that had an even exponent, will have even multiplicity. And the x plus 2, because its factor has an exponent of 1, we'll say it has an odd multiplicity. That's everything I need for 2a. I'll move on to 2b and see where it takes me. So determine whether the graph crosses or touches at the x-intercept. For part 2b, if the multiplicity is even, the graph bounces off the x-axis, and that's what I'm going to use for the word touches the x-axis, meaning the graph will touch the x-axis but not cross the x-axis. When you have even multiplicity, the graph bounces off, or we could say it touches the x-axis. And when you have odd multiplicity, the graph crosses the x-axis. So at the negative 2, 0, the graph is going to cross the x-axis as opposed to touch the x-axis. There's no extra algebra for part B. It's just understanding the relationship between the multiplicity and whether the graph bounces off the x-axis or crosses the x-axis. If you have even multiplicity, the graph bounces off or touches the x-axis and doesn't cross it. If you have odd multiplicity for an x-intercept, the graph crosses the x-axis. Moving on to part C, determine the maximum number of turning points. That's a new concept. I should probably yank out another sheet of paper and talk about it. I was going to talk about that in that introductory video, but it's getting way too long. I figured I could throw it in here. So I'll say for the maximum number of turning points, the maximum number of turning points in the graph of a polynomial only can be found if the parentheses are cleared. Which is unfortunate. And the maximum number of turning points equals the highest exponent after the parentheses are cleared minus 1. So in order to do part C, to determine the maximum number of turning points on the graph, I have to clear the parentheses, and then I'll find the highest exponent that I see and subtract 1. I'll be kind of inefficient when I do problem 2C, and then I'll show you how to be more efficient as we get deeper into this. So the maximum number of turning points is going to be 1 less than the highest exponent when the problem's multiplied out. So when I'm doing part 2C in problem 2, to do part C, I should just put it on a different sheet of paper. So to do part 2C, the maximum number of turning points, the function needs to be multiplied out. So the function is f of x and is equals to x minus 5 squared times x plus 2, which is x minus 5 times x minus 5 times x plus 2. Let me multiply that out. I'm going to FOIL it. First are going to be x times x, which are x squared. Outers are x times minus 5, which is minus 5x. Inners are minus 5 times x, which is minus 5x. Last are minus 5 times 5, which is plus 25. This is going to give me f of x equals to x squared minus 10x plus 25 times x plus 2. And now I'm going to go x squared times x. And that's going to be x cubed. And then x squared times 2, which is going to be 2x squared. And then minus 10x times x, which is minus 10x squared, and then minus 10x times 2, which is minus 20x, and then 25 times x, which is plus 25x, and then 25 times 2, which is plus 50. I don't need to combine like terms, I just need to know the highest power term. The highest power term is x cubed. The maximum number of turning points is the highest exponent minus 1. So the maximum number of turning points is 3 minus 1, or 2. So this could have at most 2 turning points. So this was woefully inefficient. The slick way to figure out the maximum number of turning points is to do a lot less multiplication. I'll show you in the next problem how I can get an answer to this question without doing so much multiplication. And but I'll save that for the next problem. Done with part C. Part D, I'm really focused on my calculator. I can't get a graph that's really accurate without my calculator, unless I know calculus, and we're not doing calculus, so we're going to have to use our calculator to sketch a graph. One thing that's going to be important when I go to graph this is to know a reasonable window to use. And for your problems, I wrote a window that's going to be suitable for your graph. I'm going to hope your window and my window is going to be suitable for me as well, and I'm going to gamble that that's the case. So I'm going to graph my function with this window in mind. When we go to do a test, I'll give you a blank graph that the x and the y-axis are marked out, so you'll know what window to use. It'll be implied from the graph. So I'm going to enter my function, x minus 5 squared times x plus 2. And I hope this window works. I didn't check on it, but our functions look a lot alike. So I'm going to go negative 10x min, positive 10x max, negative 10 y min, positive 15 y max. That will definitely work on your problem. I'm not sure if it's going to work on mine. It may be that my y max may have to be a little bit bigger, but I'll hit graph with this window and see, and it does going to have to be a little bit bigger. I have a turning point that's higher than your turning point. I'm going to cheat on mine and just make my y max really big, like 50, and see what it looks like. Oh, beautiful. So that's what my graph is going to look like. Very specifically, I'm asked to plot the x-intercepts and the turning points. Well, the x-intercepts that I came up with are negative 5, 0, and negative 2, 0. So I'm going to plot on my x-axis 1, 2, 3, 4, 5, 0, which is one of the x-intercepts, and negative 2, 0, which is the other x-intercept. Now I need to get the turning points. There's 2 turning points, and one of them I know for certain, because where a graph touches the x-axis, you get a turning point. So one of the turning points is going to be at 5, 0. That's that point right there. So this is going to be a turning point. So this part of the graph is going to go there, and it's going to go up to the other turning point, and I don't know where the other turning point is, so I need to find that turning point on my calculator. I have to know whether the turning point is a maximum or a minimum point to be able to find it on my calculator. The turning point that I don't know is a maximum point, so I'm going to find the turning point on my calculator doing this. So finding a turning point. You have to know whether it's a maximum or a minimum. In this case, it's a maximum. To find a turning point that's a maximum, first I hit the second button, and then I hit the trace calc key. I'm really looking for the calc, so I hit the second button, and then the trace key. And then I arrow down to number 4, so I'm going to cursor down to the word that says maximum, because this is a maximum point, not a minimum point. And then I hit enter. So this is the first time I'm actually hitting enter. When I hit second in calc, I didn't hit enter. It went down to number 4, now I'm going to hit enter. My calculator gives me the word left bound. What I need to do is use my left cursor and trace to the left of the max point and hit enter. So I can't see my cursor. There it is. And now it's to the left of the high point, and my calculator says left bound. I'm going to hit enter a second time. And then my calculator changes the word left bound to right bound. And in that case, I'm going to use my right arrow. I'm going to trace right of the max point. It hit enter again. It's my third time hitting enter. So I'm tracing with my right arrow. I get to the right of the max point. Now I'm to the right of the max point, and I hit enter. My calculator is going to change the word right bound to guess. Then I'm going to use my left arrow one more time and trace close to the max point and hit enter a third time. And usually I'm going to have to round to 2 decimals. That's probably going to be the case here. So I'm going to left, 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 get close to it, hit enter. So my maximum point rounded to 2 decimals is the point 0.33 comma 50.81. That's my turning point, and it's a local maximum. I'm going to show that on my graph. So on my graph, I need the point 0.33 50.81, and to get that point 0.33 comma 50.81, I need my y-axis to get up to 50. I'm going to increment my y-axis by 10. So I'm going to go 10, 20, 30, 40, 50. 0.33 is just off the x, off the origin, and then up 50. So I'm going to call that the point 0.33 comma 50.81. And now I'm just going to make graph that looks just like my picture. So it crosses the x-axis at the x-intercept of -2, 0. It goes up and it gets to the turning point, and then it goes down, gets to the other turning point, which is the x-intercept of 5, 0. My graph doesn't look exactly like my calculator's graph because the window is different. If I changed my window and changed my x max like to 5, it'll start to look more like it, I think. Maybe it'll look less like it. If I changed my window to be like -5 to 5 on the x's, maybe it'll start to look more like it. It kind of does. So the reason my graph started to look a little bit different than my calculator's is because my window of my picture here in the window that it is a little bit different. But I have a graph going perfectly fine. Goes through the x-intercept, the turning point, the x-intercept, which is the turning point because it had even multiplicity. Perfect graph, good enough. So that's the answer for part D of number 2. Part E says describe the end behavior. I'll put arrows at the end of my graph. If an arrow is pointing down, it falls. If an arrow is pointing up, it rises. This is the left side, so for part 2E, we'll say that it falls on the left-hand side, or to the left of the y-axis. This arrow is to the right of the y-axis, and it goes up. We're going to say it rises to the right of the y-axis. Last part, state the intervals where the function is increasing and decreasing. To state the intervals where the function is increasing and decreasing, on the x-axis, I'm going to put -infinity, +infinity, and the x-coordinate of the two turning points. So 0.33 and 5. But to create intervals, the first interval I'm going to create is -infinity to 0.33. That's going between those numbers. And then 0.33 to 5. And then 5 to infinity. The first interval, the graph as I move from left to right is getting higher. That's going to be an increasing interval. The middle interval, as I move from left to right, the graph is going lower. That's going to be a decreasing interval. So the interval from 0.33 to 5 is a decreasing interval. And the last interval, as I move from left to right, the graph is getting higher. That's a second increasing interval. I'll put that with the increasing and put a union symbol between the two. That's everything for number 2. Your problem 1 should work the same way. For your problem 1, you have to do all the parts. So the problem is x minus 3 squared times x plus 1. You have to first list the x-intercept and the multiplicity, determine whether the graph crosses or touches, maximum number of turning points, which I'll show you a shortcut to here in a second, sketch a graph, end behavior, increasing and decreasing intervals. Alright, so moving on with 18 minutes into one problem to problem 4. So for problem 4, I'm given the function x minus 2 cubed times x plus 1, and the first thing I'm going to do is list the x-intercepts and their multiplicity. So as I go to do problem 4a, to find the x-intercepts, you take the function and set it equal to 0. I can write it without the exponent if I want to. And then go x minus 2 equal to 0, x minus 2 equal to 0, x minus 2 equal to 0, x plus 1 equal to 0. These you all add 2 to would give me x equal to 2, x equal to 2, x equal to 2. This one you'd minus 1 from both sides and get x equal to minus 1. So I'm only going to have 2 distinct x-intercepts. My x-intercepts are going to be the 0.20 and -10. For the multiplicity, the exponent for the x minus 2 is odd, so I have odd multiplicity. The exponent for the x plus 1 is a 1, which is an odd number, so it has odd multiplicity. Done with 4a, move on to 4b. 4b, determine whether the graph crosses or touches the x-axis. So for 4b, because both of the x-intercepts have odd multiplicity, the graph will cross the x-axis as opposed to touch. The graph will touch the x-axis when you have even multiplicity, cross the x-axis when you have odd multiplicity. For part C, determine the maximum number of turning points. This is where I need to be slick. So for part C, I should, to figure out the maximum number of turning points, multiply, FOIL all this monstrous term out that I set up in 4a. That's a ridiculous task to do. You can figure out the first term, the highest exponent term of x, by just multiplying the first term in each parentheses. So if I was to FOIL all this out, the highest exponent term of x is going to be x to the 4th. So without doing a massive amount of FOILing, to figure out the highest power of x term, if you multiplied all 4 parentheses out, just multiply all the first, the highest power of x that occurs is 4. So the maximum number of turning points is going to be 4 minus 1, which is going to be 3. The answer to part C, there's at most 3 turning points. Done with C, I'm going to move my way on now to part D, sketching a graph and labeling the intercepts. The intercepts that I need to show are the points 2, 0 and the negative 1, 0. So when I go to sketch my graph, I have to make sure to plot the point 2, 0 and negative 1, 0. Let me pull out another sheet of graph paper because this is not going to be set up at all for what I need to do. In fact, let me just freehand graph it and I'll be probably better off. So I'm suggesting for your graph to do a window of negative 10 to 10 on the x's and negative 300 to 300 on the y's. 7, 8, 9, 10, and 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There's my negative 10 to 10 on my x's, and I need to plot the point I need to plot the point 2, 0 and negative 1, 0, which are the 2 x-intercepts that I computed. Now I'm going to graph this and see if I can find how many turning points there are and finish it up. So x minus 2 up arrow cubed times x plus 1. I'm going to gamble on your window. I think it's going to be okay, but I don't know that for a fact. So window negative 10 to 10, negative 300 to 300. Graph it, see what I get here. That's a wretched window. How could it be such a bad window for... Let me graph yours real quickly to make sure that I did well with your window. X minus 3 up arrow, really? X minus 3 up arrow cubed times x plus 4 wow. And for your graph it's really fine. For my graph, y equals x minus 2 cubed times x plus 1. How could it be so much worse? But it just is. My window can't be that at all. I think mine's going to be just a standard. Let me put my y's down to negative 10 to 10. How unfortunate. Yeah. Wow. I don't know why yours, with the just subtle difference, needs such a big window, and mine can handle such a small window. It's kind of shocking to me. So here's an x-intercept of 2, 0. It kind of flattens out there because it has an x cubed. but it's not a turning point, and there's my x-intercept at negative 1, 0, and it goes straight through it because it doesn't have an exponent to make it kind of smooth out. So the only turning point I see is the one turning point right there. That's what I need to find. It's a minimum point. I'm going to find it by going second, Calc, going down to option 3 that says minimum. I'm going to use my left arrow. I'm going to trace to the left of the low point, then hit enter. Use my right arrow, trace to the right of the low point, and hit enter, and then get close to the low point and hit enter. And the turning point that I'm going to need to plot on my graph is the point negative 0.25, comma, negative 8.54. So I already have my x-intercepts plotted. And I'm going to plot this point and then sketch something that looks just like that through it. So I need to get down to negative 9. 2, 3, 4, 5, 6, 7, 8, 9. So this is negative 8. This is negative 9. My turning point is actually right around here. Negative 0.25, negative 8.54. So my turning point of negative 0.25, comma, negative 8.54 is right about there. And now I'm going to just copy this the best I can. So I have my graph go through the turning point, crossing at the x-intercept. It's not as nice as my calculator's graph, but they never will be. That's close enough for my purposes. It definitely isn't a good, these aren't exactly the same, but the important part is it goes through the x-intercepts and it goes through the turning point reasonably well. If I could copy that better, I would. Usually when I make my solutions manuals, I just have a computer program graph it for me. All right, so that's the end of part D, sketching a graph. For part E, I'm describing the end behavior. On both ends, I'm going to make arrows that are pointing up. So for 4E, I'm going to say it rises to the left of the x-axis of the y-axis, and it rises to the right of the y-axis. Because both arrows are pointing up. For the increasing and decreasing part, which is the last part, which is 4f, state the intervals where the function is increasing and decreasing, I'm going to put negative infinity and positive infinity on the edges of my x-axis, and the x-coordinate of the turning point, which is negative 0.25 between the infinities. That's going to create an interval from negative infinity to negative 0.25, and an interval from negative 0.25 to infinity. In this first interval, as I move from left to right, the graph is getting lower, so this is going to be a decreasing interval. And in the second interval, the graph is kind of meandering higher. This is going to be an increasing interval. When I go to answer 4f, I'm just going to say exactly that. So for 4f, I'm going to say it's increasing in the interval negative 0.25 to infinity, and it's decreasing in the interval negative infinity to negative 0.25. All right, so go ahead and give number 3 a go with that window, not the lovely negative 10 to 10 window that I was able to do with mine. And I'll move on and do number 6. So as I start number 6, the first thing I need to do is find the x-intercepts. Find the x-intercepts by just taking the function and setting it equal to 0. So for 6a, I'm going to take the function. Eventually, I need to speed up. So I'm finding the x-intercept by setting the factors equal to 0. This, when I set it equal to 0, is going to give me x equal to negative 2. This, when I set it equal to 0, is going to give me x equal to positive 2. This, when I set it equal to 0, is going to give me x equal to negative 6. My x-intercepts, there's going to be 3 of them. It's going to be the point negative 2, 0, positive 2, 0, and negative 6, 0. In terms of multiplicity, each one of these has an implied exponent of 1. So each one of the factors is going to have odd multiplicity. You need an exponent of like 2 or 4 to get even multiplicity. Move on to part B. For each one of these, because they have odd multiplicity, the graph is going to cross the x-axis as opposed to bounce off or touch it. Alright, so that's easy, quickly done. Part C, determine the maximum number of turning points. All I'm going to do is I'm going to multiply this times this times this. When I go to do part 6C, the maximum number of turning points, the highest exponent when you multiply this out is going to be 3, because you'd multiply the x times x times x and get x cubed. So the maximum number of turning points is going to be 1 less than that. So that will have at most 2 turning points. Done with part C, on to calculator work. Sketch a graph and approximate the turning points. So I'm going to need to plot those 3 x-intercepts, negative 1, 0, 2, 0, and negative 6, 0. And I'm going to freehand this because I don't think the graph that I provided myself is going to work very well. So I'm going to have to plot the 3 x-intercepts. One of them is at the point negative 2, 0. A second one is at the point positive 2, 0. And the last one is at the point negative 6, 0. I'm going to gamble on your window because our functions look so much alike. Why shouldn't that window happen to work? But if it doesn't work, I'll tweak on it and get it to work. So I'm going to go y equals clear x plus 2 times x minus 2 times x plus 6, window negative 10 to 10 and negative 80 to 80. I might have to tweak those y's if it doesn't fit so well. I don't feel so bad about that. So I'm going to leave that window. I'm going to find these 2 turning points. So my turning points, I'm going to round each to 2 decimals. I'm going to wind up plotting it. So to get this turning point, it's a maximum. I go second calc, go down to maximum, use my left arrow, get to the left of the maximum point, and hit enter. Use my right arrow, get to the right of the maximum point and hit enter, and then get as close as I can to the maximum point and hit enter. I'm going to call that negative 4.31 and 24.63. And then next one, second calc, minimum, trace, get to the left side of that low point, minimum point, and hit enter. Trace to the right side of that minimum point and hit enter, and get as close as I can to that minimum point and hit enter. And that gives me 0.31, negative 24.63. So I'm going to plot those points and then draw a picture that looks like this. So negative 4.31, I need to make my y-axis, maybe axis goes by 5. So this is probably what you're stuck doing because you probably won't have graph paper at your fingertips that will work for this, and that's fine. So negative 4.31, 24.63, I'm going to call that. And then positive 0.31, negative 24.63, I'm going to call this. And this I'm going to connect through these points. I'm going to go through my x, cross at my x-intercept, get to the maximum point, turn down, go through the next x-intercept, cross, get through the minimum point, go up and cross at the x-intercept. So my calculator is kind of much smoother, but this is a reasonable picture for what's happening to this graph. It has all the features labeled well enough to be accurate. So done with part D. Moving on to part E, the end behavior. This arrow points down, that arrow points up. So for 6E, for this arrow, I'm going to say it falls to the left. And for that arrow, I'm going to say it rises to the right. And notice I got rid of the words to the. Part F, do the increasing and decreasing intervals. So for 6F, I need the increasing and decreasing intervals. The first interval I'm going to concern myself with is going to be this interval that goes from negative infinity to negative 4.31, and the graph is increasing in that interval. So in the interval from negative infinity to negative 4.31, the graph is going to be increasing. The next interval is going to go between this x-coordinate and this x-coordinate of the turning points. It's going to go between negative 4.31 and 0.31, and in that interval the graph is decreasing. So in my decreasing answer, I'm going to say negative 4.31 comma 0.31. And then my last interval is going to be from this turning point, which has an x-coordinate of 0.31, to the far right edge of the x-axis, which has an x-coordinate of infinity. This is going to be an increasing interval as well. So I'm going to put the 0.31 comma infinity in my increasing. Alright, so you have problem 6 or 5 to deal with. With the window that I suggested, you have to do all the parts. Find the x-intercepts, the multiplicity, state whether the graph crosses or touches, maximum number of turning points, sketch a graph, do the end behavior and the intervals where the function is increasing and decreasing. I'm going to move on to number 8. And then the first thing I'm going to do in number 8 is part A. I'm going to find the intervals where the graph is increasing. I'm going to find the x-intercepts and the multiplicity. So for 8A, I need to do the x-intercepts. And I do that by taking the function and setting it equal to 0. Technically, I should go x plus 4 times x plus 4 times x minus 3 equal to 0. Both of these are going to give me x equal to negative 4, and this is going to give me x equal to 3. So for my x-intercepts, I'm going to say it's the point negative 4, 0 and positive 3, 0. Also need the multiplicity. The x plus 4 had an exponent of 2, so it has even multiplicity. The x minus 3 has an exponent of 1, so it has odd multiplicity. Part B is whether the graph crosses or touches. At the point negative 4, 0, it's going to touch and give me a turning point because of the even multiplicity. And at the point 3, 0, it's going to cross because of the odd multiplicity. 8C wants the maximum number of turning points. I do that by just multiplying this x times that x times that x. When you multiply those x's together, you're going to get x times x times x, which is x cubed. The maximum number of turning points is 1 less than that, so the maximum number of turning points is going to be 2. That's everything for this screen, and part D is to sketch a graph labeled the x-intercepts and the turning points. Turning points I don't have yet, so I'm going to work on getting the turning points. X-intercepts I do have. Negative 4, 0, and 3, 0. So as I go to sketch a graph for problem 8, this is going to be 8D, sketching my graph. The x-intercepts that I have to plot are the points negative 4, 0, which is going to be a turning point, and 3, 0. And let me see now what I can come up with here for this graph. So clear this out and do x plus 4 squared times x minus 3. Try this window. Hopefully it does well. Might have to be bigger because my numbers are bigger. So negative 10 to 10. Let me just leave this. I'm going to try negative 50 to 50. Yours for negative 20 to 20 will work. Haha. I needed to even go down further. Let me go negative 60 to 60. Getting better at predicting these windows. If our numbers are slightly different, it's going to make the windows have to be a little bit different. Alright, so there's a turning point at negative 4, 0. There's an x-intercept at 3, 0. I need to get that turning point. That's a minimum. So I go second calc, minimum. Trace to the left of that low point, hit enter. Trace to the right of that low point and hit enter. And trace to that low point and hit enter. Yeah, what a horrible number. So it's 0.67 comma negative 50.81 for the extra turning point, along with the point negative 4, 0. So I'm going to plot this the best I can now. I'm going to plot the point negative 4, 0, which is a turning point because it has even multiplicity. 3, 0, which is not a turning point because it has odd multiplicity. And 0.67 negative 50.8, I'm going to get really crude here and call this the point 0.67 negative 50.8 without even making marks on my y-axis. And now I'm going to draw this. I'm going to go up, bounce off the turning point, that's the x-intercept, get to the next turning point, and then go through the x-intercept and keep going up. So this is, for me, pretty stellar graph. So that's the graphing part. There's my 8D. My 8E wants the end behavior. This arrow goes down, so we're going to say it falls to the left. This arrow goes up, so we're going to say it rises to the right. 8F is the increasing and decreasing intervals. So I'm going to create those intervals. The first interval I'm going to write is negative infinity to the x-coordinate of the first turning point, which is negative 4. And then negative 4 to the x-coordinate of the second turning point, which is 0.67. And then 0.67 off to infinity. I don't put this x-intercept on. It's not a turning point. The first interval from negative infinity to negative 4, the graph is increasing. So I'm going to write that in my increasing answer. The middle interval from negative 4 to 0.67, the graph is decreasing. And in the last interval, 0.67 to infinity, the graph is increasing. Rather than explaining every bit of every problem, I'm starting to be a little bit less hand-holding and showing some answers that I hope you can get without me showing you. So try number 7 and do exactly the same bits here and see where that takes you. I have 3 or 4 more problems to do for this video, and then we'll make a part 3. So the rest of the problems between 1 and 16, I don't know if they're easier, but they could be easier for the most part. They're not factored, which means when I go to do the x-intercept, I'm going to have to factor them. So for problem 10, part A, listing the x-intercepts and the multiplicity, I need to take the function and set it equal to 0. Can do that by factoring. It's not factored, so I'm going to need to factor it. For the factor of x plus 1, when I set it equal to 0, I'll get x equal to negative 1. For the factor of x minus 7, when I set it equal to 0, I'll get x equal to 7. So I'm going to get 2 x-intercepts. They're going to be negative 1, 0 and positive 7, 0. And in terms of the multiplicity, both the factors have an implied exponent of 1, so they both have odd multiplicity. 10b is stating whether it crosses or touches. And for both of these, because they have odd multiplicity, it's going to cross. 10C is the maximum number of turning points. It's already multiplied out, so that makes this part easier. I just take the highest exponent in the problem and lower it by 1. 2 minus 1 is 1. There's at most one turning point. Everything that I can do other than the graph is done, so let me do a graph right now. So I'm going to move on to 10D and make a graph. It's just a parabola. So for 10D, I'm going to sketch a graph. I'm going to put my x-intercept of negative 1, 0 on my graph, and my x-intercept of 1, 2, 3, 4, 5, 6, 7, 0, and put it on my graph. Also need to get the turning point, which is going to be the vertex of this parabola. I'm going to use that window, and hopefully that works just fine. Basically the same problem. You think it should work just fine. So y equals clear x squared minus 6x minus 7, window negative 10 to 10, negative 20 to 20. Looks fine. That turning point's a minimum point. Let me find it by going second, calc, going down to minimum, trace and get close to the vertex but to the left of it and hit enter, trace and get to the right of the vertex and hit enter, and then get as close as I can to the vertex and hit enter. That vertex I'm going to say is the point 3 comma negative 16. So somewhere's down here, there's a vertex. It's at the point 3 comma negative 16. Just going to sketch that parabola now. So I'm going to have my graph go through the x-intercept, cross the x-axis, go through the turning point, which is actually the vertex, and then go through the next x-intercept, cross at that. So that's the end of 10D. For 10E, both these arrows point up, so we're going to say it rises to the left, and it rises to the right. For the increasing and decreasing, I'm going to put the turning point, negative infinity, and positive infinity on my x-axis. That's going to make an interval from negative infinity to 3 and an interval from 3 to infinity. In the first interval, the graph is decreasing. In the second interval, the graph is increasing. So when I go to do part 10F, I'm going to say the graph is increasing in the second interval from 3 to infinity. It's decreasing in this first interval from negative infinity to 3. If you're going on to calculus, you're going to relive all this stuff using calculus to get the answers. So it's real important to understand all the concepts of rising and falling to the left and right, intercepts, touching and crossing, increasing and decreasing, turning points are all going to be important concepts in calculus. All right, so give number 9 a go. And to save time, I'm going to vote on skipping 11 and 12 because it's already getting pretty long. 11 and 12 are a lot like 9 and 10. And I'm going to move on and do 14. So my problem 14 I think is quite a bit harder than your 13. And I think it might confuse you more if I did 14. So I'm just going to do problem 13 and see where that takes me. For 13a, I'm going to find the x-intercepts by taking the function and I'm going to set it equal to 0. I'm going to pull out a common factor of an x. And then I'm going to factor what's left in the parentheses. So hopefully your factoring skills are decent enough that you could factor this even if I factored it a little bit quick. This video is getting a little bit long, so I'm trying to, some of the intermediate algebra stuff, not focus on so much. Now I'm going to set each of the factors equal to 0. This gives me x equal to 0. The middle one gives me x equal to 1. The far right one gives me x equal to 5. So for my x-intercepts, I'm going to say it's 0, 0, 1, 0, and 5, 0, and each one of these has an odd exponent of 1. So for the multiplicity, for each of these, it's going to be odd, odd, and odd. For part B, whether it crosses or touches, at 0, 0, because it has odd multiplicity, it's going to cross. At 1, 0, because it has odd multiplicity, it's going to cross. And at 5, 0, because it has odd multiplicity, it's going to cross. All right, 13C is the maximum number of turning points. It's always, if it's multiplied out, 1 degree less or one number less than the highest exponent, so it's going to have a maximum of 2 turning points. I actually think it has 2 turning points. Now I'm going to use my window and graph your function for 13D. So I'm going to y equals, and I already graphed it to make sure that window was going to work. I use the window negative 10 to 10, negative 20 to 20. The graph looks like that. I'm going to get 2 turning points. Second calc maximum for the left turning point. Get to the left of it, hit enter. Get to the right of it, hit enter, and get close to it and hit enter. That turning point's the point 0.47, 1.13. The second turning point, second calc, that's a minimum point. Get close to it, but onto the left of it, hit enter. Move around to the other side, hit enter, and then enter again. And I get 3.52, negative 13.13 as my turning points. I also have 3 x-intercepts, 0, 0, 1, 0, and 5, 0 to plot. So these are all the points I'm going to plot, 0, 0, 1, 0, and 5, 0. So I have 5 points to plot, and then I'm just going to connect them with a graph that looks like that. So 0, 1, 2, 3, 4, 5. Here's the point 0, 0. Here's the point 1, 0. Here's the point 5, 0. And then I'm going to do my y-axis by 10. So there's 10, negative 10, negative 20. 0.47, 1.13. It's really kind of bumped right up around here. So I'm going to call that 0.47. 1.13. It's probably a little bit high, but I can live with that. And then 3.52, negative 13.3. I'm going to call this that. And now I'm just going to draw. Cross, cross, turn. Again, it's distorted a little bit, but I'm completely content with this distorted graph for at this point in the video. So there's my graph. For part E, I look at the arrows. This arrow is going down, so we say it falls to the left. That arrow is going up, we say it rises to the right. Now the increasing and decreasing part. On my x-axis, I'm going to go from negative infinity to that turning point, 0.47, and then between these two turning points, 0.47 to 3.52, and between this turning point and the end of the x-axis. So for the increasing and decreasing, the first interval it's increasing. As I go to do 13F, for my increasing, I'm going to write negative infinity to 0.47. The next interval, it's decreasing. That's the interval from 0.47 to 3.52. And the last interval from 3.52 to infinity, it's increasing. So that's everything for your problem 13. We just have one problem each to do. You can do 15, I'll do 16. And we'll see how these go. So for 16, part A, find the x-intercepts in multiplicity. A little bit harder because I've got a factor and there's a bigger common factor. So for 16A, I'm going to take the negative 2x to the fourth plus 18x squared and set it equal to 0 to find my x-intercept. Pull out a common factor of negative 2x squared. When I do that, I'm going to be left with x squared minus 9. Factor that x squared minus 9. This negative 2 is going to mess me up. It's a numerical common factor. If I have a problem that has a numerical common factor and there's an equal sign, I can divide it out. It's going to make it easier if that factor is gone. So I divided both sides by negative 2 and got that. Now I'm going to go x squared equal to 0, x plus 3 equal to 0, x minus 3 equal to 0. This gives me x times x equal to 0. This just gives me x equal to 0, but it has even multiplicity. This gives me x equal negative 3. This gives me x equal to positive 3. My x-intercepts are going to be the points 0, 0, negative 3, 0, and positive 3, 0. This one has even multiplicity because the exponent is 2. The other two have odd multiplicity because the exponents are 1. For part B, the touches and crosses, at the point 0, 0, it's going to be a turning point. The graph is going to touch. And at the other two, because of the odd multiplicity, they're not going to be turning points, and the graph is going to cross. For part C, the maximum number of turning points, this is a 4th degree polynomial, so you could have at most 3 turning points. It's always one less than the highest exponent. And that's the maximum number of turning points. You may not have 3 turning points. I think this one does, though. So that's the A, B, and C. Now I'm going to go and do a graph. I'm going to make sure to plot those intercepts and the turning points, but I need to find the turning points with a graph. Hopefully my window and your window is going to be the same. It may not be, but I know I'm going to have to plot the x-intercept of 0, 0, which is going to be a turning point because it has even multiplicity. And the point negative 3, 0 and positive 3, 0 aren't going to be turning points because they have odd multiplicity. So on y equals clear negative 2x up arrow 4th plus 18x squared window negative 5 to 5 and negative 20 to 20. Let's see what that looks like. Mine needs to go higher. Mine's going to do negative 30 to 30, maybe negative 40 to 40, but it will work for your graph will work fine with that window. Even higher, it's 40s for mine. So I see the 3 x-intercepts, negative 3, 0, and positive 3, that I'm going to show up at x equal to 3, x equal to 0, and x equal to negative 3. I have the x-intercepts. I'm going to get these 2 turning points. Those 2 turning points look to have the same y. I'm going to go second calc, their maximums. I'm going to get the first one by using my cursor, tracing to the left of that maximum, hit enter, to the right of that maximum, hit enter, get close to that maximum, hit enter, and I get to the point negative 2.12 comma 40.5. Now I'm going to go over here and do that one. Second calc maximum. I don't need that one. That's 0, 0. Hit enter, right around, enter, and enter. That's going to be 2.12 comma 40.5. So those are the 5 points I need to plot. I already have 3 of them plotted. I just need to get these turning points. I'm going to call this 40 on my y-axis and kind of fudge. So 1, 2.12, 40.5 is that point. And then negative 2.12, 40.5 is that point. And now I'm going to connect these. I go up, turn, 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 down, more or less like that. Both of the arrows at the ends of my graphs are going to be going down. So when I go to do part E, the end behavior, we're going to say it falls to the left and it falls to the right because both of those arrows are pointing down. Now I need intervals for increasing and decreasing. The first interval is going to go from negative infinity to negative 2.12. The middle interval is going to go from negative 2.12 to 0. The next one's going to go from 0 to 2.12. And the last one's going to go from 2.12 to infinity. So I have, 1, 2, 3, 4 intervals to worry about. The first interval, the graph is going to be increasing. So for my increasing part, which is 16f, it's going to be increasing from negative infinity to negative 2.12. Next interval, which is negative 2.12 to 0, it's decreasing. Next interval, it's increasing from 0 to 2.12. Last interval, it's decreasing from 2.12 to infinity. Your 15, the graph should look the same. It should work the same. So I'm going to stop this, and then we have a second part to this, which is kind of a completely different concept. It's not graphing, so it'll fit better in a different section, a different part.